In this video, what we're going to discuss is all about Pythagorean theorem. So this theorem is actually one of the most useful and convenient um, tool in solving problems relating to triangles. So what does it do is that it shows simply, it makes an equation, and that equation shows the relationship among the sides of a right triangle. So keep in mind that what we're trying to solve are problems involving right triangles. So Pythagorean theorem is only limited to right triangles. So specifically, what does it do is that it is used to find the measures of unknown sides when two other sides are known. So in a triangle, for example, in a right triangle, when two sides are known, let us say 8, 5, we can use this two knowns to find this unknown side. So that is actually the end goal of Pythagorean theorem. But before that, let us first introduce and identify the important parts of the triangle. So we have the hypotenuse first. This is the longest side in a right triangle. To locate this one, it's the opposite of the right angle. Then we have also the legs. These are the sides that make up the right angle. So there are two legs. So if we say we have a right triangle like this, okay, this is our hypotenuse. That's the opposite to the right angle, and the sides that make up the right angle, this one, are actually the legs. So going back here, the legs are in figure number 1, the legs are side A and side B, while the hypotenuse is C. In number 2, the legs are, because the right angle is here, so the side that make up the right angle are the legs. Therefore, Y and Z are the legs. And since the opposite of the right angle, that's the x, therefore the hypotenuse is x. So in figure 3, the legs are R and S, and the hypotenuse is T. So you see, it is very important that when we deal with right triangles with respect to Pythagorean theorem, we know exactly which is the hypotenuse and which are the legs. So now we are ready to derive the equation or the formula or the relationship among the sides using Pythagorean theorem. So as you can see here, we have two identical squares. Okay, we can use of the grid itself. Okay, in figure A and in figure B, as you can see, there are 4 right angles in figure A and 4 right angles in figure B, and they are all congruent triangles. They are all congruent triangles rather. So as you can see, the triangles in green, if you're going to look at that, has legs of A and B and has a hypotenuse of C. That will be clear. So since the square are identical, they are congruent, they are of the same size, okay, and the triangles are also congruent, meaning the four triangles in the four green triangles in A and the four green triangles in B, they are congruent, meaning if we're going to remove the green triangles, since they are of the same shape, meaning they are of the same size and shape, they are of the same area, meaning the remaining figure will be the blue. If we're going to remove all of this, the green, and remove this, the remaining figures are the blue figures. So since we remove the same thing, the same area in A and in B, the remaining figures will have also the same area. Okay, so as you can see in the left side in A, the figure A, the remaining figure is a square with a side, with each side is C units, while in the figure B on the right, it composes of two squares, with the larger square is has B units as length of the sides, then the smaller square has A units as lengths of the sides. So if we're going to get the area of a square, we simply square the sides. So therefore the area for this is simply C square. And the area for this larger square is B square, and the area for this smaller square is A square. Now we know that their area, the area in A is equal to the area in B. Why? Because of the premise that we remove the same areas, which are the green triangles. So meaning C square is equal to A square plus B square, the sum of the two squares. So this is actually the equation for Pythagorean theorem. Okay. So going back a while ago, this is A, B, and C. So as you can see, it seems that we just simply square the sides of the legs, then add them. That is equal to the square of the hypotenuse. Okay, it seems like again we just take the squares of the legs, add them together, and that is equal to the square of the hypotenuse. So if we're going to replace that, you say hypotenuse square, to make it not confusing, then the legs, we can say the first leg, then square that, then the second leg, square that. So you can use this either of that equation. So this one, we're just referring to this as leg as hypotenuse, then but this one we're just referring to that as sides A and B being the legs and C being the hypotenuse. So what we're going to do is we apply this equation in, so let's go back later a while ago. We're going to apply this in an equation. Since the hypotenuse is C, so we say C square, A square plus B square. Take the square of the legs, add them together, that's equal to the square of the hypotenuse. The square in the figure 2 are Z and Y, so we say, and the hypotenuse is X, we say X square, and Y square, C square. While in figure 3 we have T square, being the hypotenuse, equals to the sum of the squares of the leg, R square plus S square. So that's how simply you set up the equation for Pythagorean theorem when triangles are given. So let's apply that in solving unknowns. So in this case, the hypotenuse is 10 cm. So we say the hypotenuse, 10 cm, is equals to the sum of the square of the legs. Okay, so we have 100. We solve the equation as it is 64. Then we subtract 64. we have 36 equals x squared. Since we are solving for x and not x squared, we're going to extract the square root of both sides. X equals 6 cm. Okay. So that is simply how we use the equation, set up the equation, then solve for the unknown. In figure 2, as you can see, the hypotenuse is y, because that's simply the opposite of the right angle. So hypotenuse square. So you can follow this general modified equation. You say hypotenuse square is just a square of the first leg plus square of the second leg. So the hypotenuse in figure T is y. So we say y square plus square of the first leg and square of the second leg. The square of 15 is 225. 15 square is 225. Is that 225? Two to five. This is one is 2 to 5. Then this one is 25 now. This one is 25. So you have y squared is equals to 2 to 5 plus 25 is 250. So if we're going to take the square root of both sides, we have 15.81 cm. Okay, so that's the most basic, the very basic application of the Pythagorean theorem. Now we can also use Pythagorean theorem to connect it to the area of the triangle. Okay, remember that the instruction here is find the area of each triangle. So we know that the area of a triangle is given by the 1/2 the base times the height. The base is actually should be perpendicular with the height, and these are actually the legs. Those are actually the legs. So here we need these legs to get the area. We need the 15 and this side. So in this case we cannot compute for the area because one side, the height, is not known. It's unknown. So what we're going to do is let's find first the height. So let's say this is h. Find first that before we can find the area. So as you can see, we're connecting the Pythagorean theorem and the area of the triangle. So if we can find the value of h, the height of the triangle, therefore we can now use that to find the area of the triangle. So let's find the area. So we have the value of h first. So h square. The hypotenuse is 13, so we say 13 square equals h square plus 5 square. So this one is 169. This one is 25. So if we're going to subtract 25 from both sides, we have 144 equals h square. Taking square root of both sides, so we have h equals 12. Now we know that this one is actually 12 cm. So we can use this to find that our base will be 5 cm, our height will be 12 cm. So we can use that to find for the area. To find the area of the triangle. So 1/2 base height. So 1/2, what is the base? 5. What is the height? 12. So we have 30. 1/2 of 5 times 12 is 30. That is cm square because it's an area. In number 2, it's the same. We do not have the height again. Okay, or we can simply let this as x, because we need this to find the area of the triangle. We need this measure and this measure, but the other measure is unknown, so we will use again Pythagorean theorem to solve for this x and use that later to find the area. So let us set up first an equation for Pythagorean theorem. The hypotenuse is 9 cm, so we say 9 square equals to the square of the legs, and we have 81, we have 36. Subtracting 36 both sides, we have 45. Taking square root of both sides, we have, that's 6 point something, 6.71 cm. Oh, now we know that this one is 6.71 cm. We can use this to find the area. Okay. So the area would be, again, 1/2 base times height. The base is, you can use the x as the base, depending on the perspective of the triangle, perspective of the how you arrange the figure. So you can use base as the 6 here. Then the height will be the 8x will be the 6.71 cm. Computing that, we will have 20.13, and the unit is cm square. So in this examples, we showed that we can find the area of the triangle even if one of the legs are unknown, but we have to use first the Pythagorean theorem to find that unknown leg. Okay, again, the base and height that's been referred, that's been included in the formula for area, those are actually the legs of the right triangle. So here we will venture some complicated problems, a little bit complicated. So what we're going to solve here is xcm. So as you can see, in order for us to solve for the xcm, we need these measures. This measure, we need this measure, which we have, that is 7 cm, and we need this measure here. So our problem is this side, and we can let that as, let us say, x, or let us say a. So from there, we can use 7 cm and 10 cm to solve for a first. Then after we solve for a, we can use that to find x. So as you can see, using setting up a Pythagorean theorem equation of the Pythagorean theorem using this one, we have hypotenuse is 10, so 10 square equals a square plus 7 square. This is 100, this is a square, and this is 49. So this gives us 51 equals a square. 49 minus 100 minus 49. So taking square root both sides, so we have a equals, this is around 7 point something, 7.14. So we know that a is 7.14. Therefore, the total length is actually 7.14 times 6, and that is 13.14. And we can use that and the 7 cm to solve for the x. And the hypotenuse for this is x cm equals the sum of the legs, which is the 7 square, and the 13.14 square. Adding that together, we have 221 66. Taking the square root of both sides so that we can solve for x, we have 14.89. Okay. Since this is a side measure, it's just 7 p.m. So that is the measure of x. Next is we have here. So our concern is this value, the value of a. How long is that? So from there, we can use the value of a if we have this measure. Okay. If we have this measure, using Pythagorean theorem, yes, we have 7 cm, but we do not have this measure. Let us say this is h. Okay, we do not have that, so we cannot directly solve for a if we do not have that height. Okay. And because of that, we need to use this triangle here to solve for h first. This one. So from that, the hypotenuse is 12 square equals 10 square plus 8 square. So we're just using the same equation for using the same principle, which is the Pythagorean theorem. So we can solve now. We have 144 equals 100 plus 8 square. Then we have 44 equals 8 square. Taking square root of both sides, we have h must be like 6 point something, 6.63. So from there, we can now use that to solve for this. You can use this triangle again to solve for a. So solving for a, 7 and h, the hypotenuse is h, which is 6.33. So say 6.33 square is equals to the sum of the legs, a square plus 7 square. This is wrong. The hypotenuse should be 7. So the hypotenuse should be 7. So you have 7 square equals a square plus 6.33 square. So we can rewrite the equation as like this, subtracting both sides by 6.33 square. .93. A square is 8.93. Taking square root of that, .99, or almost like 3, 2.99 cm. So what we did here is we look first, it's like double Pythagorean theorem. We solve for this first. We solve for this by using this unknown values here. Since we solved already the h, which is 6.33, we use that to solve for a eventual. Then we have the last problem is this one. So we have 15 cm, 6 cm, y cm, and 9 cm. So what we're going to do is look for the value of y. So what do we have here is that if we're going to make a Pythagorean equation using Pythagorean theorem of this triangle, there, okay, but we do not have this height. So let's say this is height. So let h be the height. Okay. So using h, y, and 9, so we can say 9 square is y square plus h square. We learned that. Then using the bigger triangle, if you use the bigger triangle here, okay, the hypotenuse is 15, so we say 15 square equals y plus 6 square plus 8 square. Okay, so we have two equations involving y and h. So now, as you can see, they are both, we can rewrite this as 81 minus y square equals 8 square. Then we can rewrite this as 15 square minus y plus 6 square equals 8 square. So as you can see here, we're just rewriting it both into 8 square so that we can make an equation of them. Since they are both equal to 8 square, meaning we can make an equation of this and that they are also equal. So we say that is 81 minus y square is actually equal to 15 minus 15 square minus, or you can say this is 2 to 5 minus the y plus 6 square. So as you can see, it's from the first equation. This one is from the second equation. So we're just using that to solve for y. So from here we have 81 minus y square equals 225 minus y square plus 12y plus 36. So if you can expand the y plus 6 square, that will be y square plus 12y plus 36. Distributing the negative both sides, we have 18y, 81 minus y square is just 225 minus y square minus 12y minus 36. Okay, so you have 81 minus y square is equal to 225, and 36 are similar terms, so we say 225 minus 36, that gives us 189. As you can see guys, both has negative y square on each side, so we can remove this plus y square, so we are actually left with 81 on the left, 189 on the right, then negative 12y. From there, we can combine 81 and 189 by subtracting 189. So it's become negative 108 equals negative 12y, because these are 0 already. That's 0, so negative 12y. So we cannot solve for y. That's the one we're solving. So divide by negative 12, divide by negative 12. Y is simply negative 108 divided by 12 is actually 9. So yeah, so therefore y is just 9 cm. Okay. So recap in this problem. We formed equation using the first smaller triangle. Using Pythagorean theorem again. We form another equation using Pythagorean theorem again, and we both equate them into 8 square, just to show that this one are also equal, since they are both equals to 8 square. We set up that equation, we expand that y plus 6 square, we combine like terms, and we got finally we got 81 minus y square equals 189 minus y square minus 12y. Subtracting, removing negative y square by adding y square both sides, we are left with 81 equals 189 minus 12, and combining 81 and 189, we got negative 108. Therefore y becomes simply 9.